Hello everybody. We now present Gabor Layers Enhanced Network Robustness, a joint work between KAUST and Universidad de los Andes that was presented at the European Conference on Computer Vision in 2020. Our central objective of study are deep neural networks, or DNNs. DNNs have provided outstanding gains in performance in several fields, from computer vision to machine learning and natural language processing. In computer vision, DNNs have been fundamental for developing systems for tasks such as recognition and detection, among many others. However, despite the impressive performance of DNN-based systems, researchers noticed that DNNs are extremely susceptible to imperceptible perturbations in their input. Such small perturbations, which produce large modifications in the output, are now known as adversarial attacks. Despite the attention that adversarial attacks have attracted in the modern era of deep features, we know that such imperceptible perturbations were not a major concern in the pre-DNN era. Standard computer vision algorithms were inspired by the perception of the animal visual system. This system reasons in terms of handcrafted features aiming at representing textures, shapes, and colors. These systems were hence structured, comprehensible, and in general terms better understood than features learned by DNNs. Despite how meaningful these features were to humans, they were then overshadowed by DNNs. In this paper, we draw inspiration from the animal visual system, as it requires robustness for ensuring the survival of biological species. Early works by Mar and Julesh argue that the animal visual system initially processes low-level agnostic information, in which the input of the system is segmented according to blobs, edges, and bars. Further, famous studies by Hubel and Wiesel demonstrated how the primary visual cortex in cats responded to wave textures. Motivated by the previous observation, we turn our attention to Gabor filters. Gabor filters are filters based on mathematical functions that are capable of modeling elements that resemble those that the animal visual cortices respond to. These filters were of customary use in the computer vision community a few years ago, where they were used for text characterization, character recognition, edge detection, and face recognition. Inspired by these facts, we hypothesized that Gabor filters possess inherent robustness properties, and that integrating these filters into DNNs can make the DNNs inherit these properties. Our work fills a gap in the literature, where we provide experimental results demonstrating the significant impact that such an architectural change has on improving robustness. In particular, our contributions are 1. We propose a parameterized Gabor structured convolutional layer as a replacement for early conv layers in DNNs. We observe that such layers can enhance robustness. Further, we exploit the closed form of the Gabor filters, derive an analytical expression for a Lipschitz constant of the filters, and propose a new training regularizer to further boost robustness. 2. We provide empirical validation of our findings on standard benchmarks in computer vision. In practice, Gabor layers are convolutional layers whose filters are dynamically generated by sampling from a continuous Gabor function. The inner workings of the Gabor layer make it easily adaptable for any model, where it can be seamlessly replaced with a few lines of code in our implementation. Furthermore, we study the Lipschitz constant of this layer, as previous work showed the relation between regularizing the Lipschitz constant of a network and its robustness. We leverage the closed form of the Gabor function to develop an expression for the Lipschitz constant of the Gabor filter. As empirical validation of our findings related to Gabor layers, we conduct extensive experiments on standard architectures and datasets. For further experiments, please refer to the paper. First, we check the clean accuracy of Gabor layer networks. In this experiment, we find that such networks can recover close to nominal test accuracy, which is good news. We also study the filters learned by our networks. Since the seminal work of AlexNet for visual recognition, Krzyzewski showed that early layers of DNNs converge to Gabor-like filters. In this work, we note that the filters that our Gabor layers learned indeed strongly resemble most of AlexNet filters. Next, we assess the robustness of Gabor layer networks by attacking them and recording their robustness, where the attacks are conducted by projected gradient descent. These are the experimental results we obtain. From these, we observe that 1. Gabor layers consistently improve network robustness, and that this improvement can be as large as 9% points. 2. Our proposed regularizer can further improve network robustness by up to 14% when compared with Gabor layer networks without the regularizer, and even 18% with respect to nominally trained models. Finally, we emphasize that our approach is orthogonal to other approaches in the robustness literature. In particular, we run experiments where we combine our Gabor layer networks with a fast adversarial training framework. Our results demonstrate how Gabor layers and the regularizer can be effectively combined with adversarial training to provide improvements in network robustness. Thank you for your attention. Our GitHub repository with the PyTorch implementation of Gabor layers can be found on the following link.